Welcome back to another lesson in Algebra 2. We're in Unit 8. Unit 8 is all about polynomials. In this lesson, we're going to look at factoring polynomials. In Lesson 1, we described what polynomials are. We discussed how to determine the degree and the number of terms, which is going to be important for knowing how to attack it. In this lesson, we're not going to look at simplifying. We're going to look at the opposite direction. We're going to look at factoring. So first, let's review a couple of the special patterns we've learned in previous lessons. In our units on quadratic functions, we learned that when you have two perfect squares subtracted, we call it a difference of two squares. And a squared minus b squared can become a minus b, a plus b. Likewise, we learned about perfect square trinomials. We know that we can square a plus b squared. We get a squared plus 2ab plus b squared, or if it's a minus, there's a minus in the middle. So if we see this pattern here, it can help us factor it into what it was before. So that's also really helpful. In this lesson, we're going to learn two more special patterns. We're going to learn the difference of two cubes and the sum of two cubes. So unlike with squares, where we only have a difference of two squares, with the cubes, we actually have sum and difference. The pattern is this. If we have two perfect cubes subtracted, that it factors into a binomial times a trinomial. And the binomial is simply the cube root of this first term and the cube root of the second term. So if this is a cubed, this is a, and then this is b. Then what we do is we square the a. And what I tell my students to do is just, once you've figured out what a and b are, just look here. Square that number, not that number, this number here to get this number. Multiply the two together and change the sign, and then square the last number. Be careful. That a squared plus ab plus b squared kind of reminds me of the perfect square trinomial, but it's not times 2, and the sign is altered. The sum of two cubes is really the same formula. When you have a cubed plus b cubed, you get your a plus b, just like we got an a minus b. And then it's, again, square the a, multiply the two together, and change the sign. This time change it to a minus and square the b. So you see it's really the same pattern. It's still, this sign here matches that, and then it switches to a minus over here. Okay, in the examples and practices in this lesson, we'll also apply these patterns. We'll review older patterns and skills, and we'll apply a new pattern called grouping. A new technique, I should say. All right, let's start by just factoring some polynomials. 2x minus 8. So this one always confuses students when they're told to factor something like this. Maybe because they don't see why you would ever want to do it. It doesn't really help you solve the equation, but we will oftentimes see in coming up units that we do want to be able to factor something like this. And what we look for is to factor out a greatest common factor, which in this case is the number 2. So it gives me 2 times x minus 4. All right, now x squared minus 81, we recognize that as a difference of two squares. So it's x minus 9 and x plus 9. On this next one, y squared plus 3y minus 10, we recognize that we need to factor it like this. So put a y and a y. And I'm going to do plus 5 and minus 2. Now we have x cubed plus 8, so we get to use our sum of two cubes pattern. You take the cube root of x cubed and the cube root of 8. 2 cubed is 8. Now I want you to look at this as if x is a and b is 2. So first you square the x, then you multiply these two together and change the sign, then you square the 2 to get 4. All right, let's try 9x minus 4x cubed. All right, first I'm going to factor out an x, giving me 9 minus 4x squared. Now I'll factor this as 3 minus 2x and 3 plus 2x. Next we have 27 minus n cubed. We get to use our difference of two cubes. 3 cubed is 27, and the cube root of n cubed is just n. Then we use this to help us figure out what to do. Square the 3, multiply the 3 and n together and change the sign, and then square the n. All right, Got a couple more here to do. We got b plus 4b. You can factor out a b because there's a b in each term, which would make that 1 plus b to the third. That's a sum of 2 cubes. So it's 1 plus b, because the cube root of 1 is 1. Then I square that, multiply it together, and change the sign, and then square that. By the way, you'll note that I'm not trying to factor these trinomials that result from this pattern. It will never be factorable. I might go back up here and mention this, that this will always be what we call prime. It won't be factorable, okay? All right, x cubed plus 6x squared plus 9x. Do you see an x in common? Let's factor it out. There we go. But this is a this is a perfect square trinomial pattern. This is the square root of that is x, and the square root of that is 3, and 3 times x times 2 is 6. So this is simply x plus 3 squared. All right, I'd like you to please pause the video and try these. All right, let's see how you did. On the first one, you should have factored out a GCF of 3x, leaving you 3x minus, not 3x, just a 3 minus x. On the next one, this is a difference of two squares. Square root of 81 is 9, so it's 9x square root of 4 is 2, 9x minus 2, and 9x plus 2. This one here, we need to factor just like we're used to our factoring a quadratic. So 2b and b would be 2b squared. And I'll say plus 3 to give me 6b and then minus 1b. So 2b squared and minus 3, but 6b minus b is 5b. Here we have our difference of 2 cubed pattern. This is y minus 4 because 4 cubed is 64. And that's y squared plus 4y plus 16. All right, let's try the next one. I'm going to factor out a 2x, which leaves me with 4 minus x squared. And I'm not going to stop there because I can factor 4 minus x squared as 2 minus x, 2 plus x. All right, once I get my sum of 2 cubes pattern, I have a plus 1. And then I square the a, change the sign when I multiply a and 1 together, and then square the 1. All right, some but not all 4-term cubic polynomials can be factored by grouping. Rarely we'll see even some higher order ones can be factored that way, but not too often. But this is a common technique that you can do for some but not all 4-term polynomials. I've got x cubed plus 4x squared plus 2x plus 8, and we need to factor it. So what we do in factoring by grouping is we group the first 2 terms and the last 2 terms. So you just put parentheses there. That's the associative property that allows me to do that. All right, I'm going to factor out a GCF of each term. So I factor out an x squared from this first group, and I get x plus 4. All right, on the second term, I can factor out a common factor of 2, and I get x plus 4. In order to be factorable by grouping, these two things must be the same. If they're not, then we can't do this. They are, so we are going to factor out this x plus 4. See how each term, I've got 2 terms now. That big thing all multiplied together with a plus in between it. Then I got this big thing. And they each have an x plus 4 in it. Do you see? So I'm going to factor out the x plus 4. I can put it in front or back. It doesn't matter. And then what do I have left over? Well, when I factor out x plus 4 out of this group I circled in yellow, all I have left is x squared. When I factor out x plus 4 over here, all I have left is plus 2. And then that's a x squared plus 2. That's not factorable anymore, so we're done. All right, let's try the next one. Let's group the first 2 terms. But this one's got a little subtlety. See how it's got this minus here? I need to be really careful as I do that. So typically what I do is I make this plus, and then in parentheses I put negative 9x minus 27. So you need to realize that that's plus a negative when it says minus. Now when I factor out a GCF, I'm going to factor out an x squared out of the first group. I get x plus 3. Out of the second group, I can factor out a minus 9. If this first term in the group is negative, factor out a negative, and that will change the sign of this next group. And I'm glad it does because it makes it match x plus 3 and x plus 3. Now I can factor out x plus 3. And I'm left with x squared minus 9. But this is a difference of 2 squares, so I'm going to go further. So bring down the x plus 3, and then factor this as x minus 3x plus 3. Then that's a perfectly fine answer, but if you want to be really clever, you can say, well, this is x plus 3 squared times x minus 3. And that's exactly right. All right, let's take a look at the next one. 2n cubed minus 3n squared minus 18n plus 27. So we will group 2n cubed minus 3n squared. And I'll say plus a negative 18n plus 27. I'll group the negative inside. 18n plus 27. Factoring out an n squared, I get n squared times 2n minus 3. And here I'm going to factor out a minus 9, giving me 2n minus 3. And it works. So I can factor out a 2n minus 3 from each term, from this term and this term. And I'm left with, in parentheses, n squared minus 9. This is factorable, though. So it's 2n minus 3 times n minus 3 times n plus 3. All right, x to the fourth plus 4x cubed plus 2x squared plus 8x. Can you see that I can factor out an x first and foremost? If every term has an x, you should factor out an x. At least. All right, now I'm going to group, and I will group according to here and here. So I have an x, and then I factored out an x squared, and I'm left with x plus 4. All right, next I'll factor out a plus 2, and I'm left with x plus 4. So now I can rewrite this as x. I'll factor out an x plus 4, and I'll have x squared plus 2 left over. I used to have parentheses on the outside, but once I finish factoring this, then everything's multiplied, so I don't need them. All right, now we're going to factor this. We're going to group the first 3 terms and the last 3 terms. That's going to be my hint. This would be a tough problem to do without this hint, but it says we can group these, so let's try it. If I group those, I can pull out an x cubed, and I'll be left with x squared minus 9x plus 8. And in the second group, I can factor out an 8, and I would get x squared minus 9x plus 8. So you'll see they have the same x squared minus 9x plus 8 involved. So I end up with x cubed plus 8 times x squared minus 9x plus 8. This is a sum of 2 cubes. It's x plus the cube root of 8 is 2, because 2 times 2 times 2 is 8. Then to finish it off, I square the first term, multiply the 2 together and change the sign, and square the last term. Now, x squared minus 9x plus 8 is also factorable as x minus 8 and x minus 1. So we've done a pretty good job breaking down that big polynomial into several different factors. All right, I'd like for you to please pause the video and work through these practice problems, and then we will go over them, okay? All right, let's see how you did. You should have grouped the first 2 terms together. Typically, with these cubic polynomials, we're looking at grouping the first 2 terms. I'll factor out an a squared, and I'm left with 4a plus 1. I'll factor out a negative 4, and I'm left with 4a plus 1, which gives me a squared minus 4 times 4a plus 1. A squared minus 4 is a minus 2, and a plus 2 times 4a plus 1. All right, let's try the next one. Group this, and then make this plus a negative, and group that negative in there so you factor it out. I have x squared times x plus 6 minus 5. I can bring a 5 out of each one, x plus 6. So this ends up being x squared minus 5 left over when I factor out the x plus 6. All right, let's try the next one. Oh, looks like we got some a's and b's. We'll group here. I'll factor out an a, b. No, I can't do that. I can just do an a. And I'm left with a squared minus 4b squared. On the next one, I'll factor out looks like a 2. And I'm left with, I can do a 2b, right? 2b to the second, actually. 2b to the second, I'm left with a. When I figure out 2b to the second, I'm left with a squared minus 4b squared. Lo and behold, they're the same, so I can factor out a squared minus 4b squared. I'm taking this whole thing out of each term, and I'll be left with a plus 2b left over. So a squared minus 4b squared times a plus 2b. All right, next one. Let's factor out an n first, because anytime, no matter what new technique I tell you, if there's an n in each term, factor out a common factor first. If you don't do it first, it just makes it harder, and then you still have to do it at the end. So there's my groups. I will factor out an n squared. I'll be left with n plus 7. And I'll factor out a plus 3, and I'll be left with n plus 7. So this becomes n on the outside. We factor out an n plus 7, and we're left with n squared plus 3. All right, the patterns and techniques we have studied thus far can only be applied to higher degree polynomials. The following example demonstrates that polynomials in so-called quadratic form, even though they are not actually quadratic. So let's talk about what quadratic form is. So the standard quadratic formula says, we have ax squared plus bx plus c. And that's easily solved with either the quadratic formula or, quite often, it's factorable. Well, it turns out that quadratic form is any time this exponent is twice this exponent. So if I have ax to the 4th plus bx squared, and then I still need cx to the 0, that I can basically factor this just like I would normally. Let's see how it works out. It's a little bit different. So notice this is quadratic form. It has 3 terms. That's a requirement. The exponent on x is twice this exponent in the middle. So what I'm going to do is just going to factor it normally. And I'm going to think, okay, well, what times what is x to the 4th? Well, this time it would have to be x squared and x squared. Then I look at 14. And I say, well, what multiplies 14? And I can tell just by looking, adds to 9. Well, that's plus 7 and plus 2. Let's FOIL to make sure. First is x squared times x squared. That's x to the 4th. Outer is x squared times 2. That's plus 2x squared. Inner is 7 times x squared, so plus 7x squared. And then lastly, a plus 14, which would give me x squared plus 9x, x to the 4th plus 9x squared plus 14. All right, let's try another one. Okay, this is again a quadratic form. I can factor it with x squared, though, instead of x. And this will be a minus 9 and a minus 1. Well, this time I can go further, because these are just difference of 2 squares, unlike earlier where they were sums. And, we're missing a squared on this one. X squared times x squared is x to the 4th. Okay, and that gives me x minus 3, x plus 3, and it's factored. All right, let's take a look at the next one. Again, these are bigger exponents, but we could still factor it. It'll be x cubed and x cubed. All right, I'm going to do plus 8 and minus 1. X cubed plus 8 is a sum of 2 cubes. So this is x plus 2 times x squared minus 2x plus 4. And then this is x minus 1, x squared, multiply the 2 together and change the sign. Sorry, x times negative x, then change the sign to a positive x, and then square the last term. And that's it. All right, well, what I need you to do now is to practice the following polynomials. Pause the video and give it a shot. All right, let's try. Okay, this is in quadratic form, so I know it has to be 2n squared times some other n squared. And let's see, if I do, let's see here. If I do 2n and I do a plus 2. No, I don't want to do a plus 2. They got to be different signs. I'm going to do a minus 2. And then I'm going to do a plus 5. That gives me negative 4n squared plus 5n squared is 1n squared, and then the negative 5. Can't do anything with the sum of squares, but with a difference of two squares I could, but this is not factorable because 2 is not a perfect square. All right, let's try the next one. X plus 4 and x squared plus 4. We're forming out for square, and then x squared minus 1. This is not factorable. It is done because that's not a difference. But this has got ways to go. All right, let's take a look at the last one. X is 6 minus 10x cubed plus 16. I can factor that as x cubed and x cubed. And let's see here. We're probably going to do minus 8 and minus 2. This one here, we're just going to call this factored because 2 is not a perfect cube. But this next one is. We can do x plus 2 times x squared minus 2x plus 4. All right, let's factor fully the following higher order degree polynomial. We can also use, we could call this a quadratic difference of two squares form. Anything with the exponents divisible by 2 is definitely difference of two squares. But instead of being like x minus 9, it's x squared minus 9, x squared plus 9. I can then factor x squared minus 9 as x minus 3, x plus 3 times x squared plus 9. All right, lastly, I can also do x cubed minus 1. But this is a difference of two cubes. This is x minus 1, the cube root of x cubed, and the cube root of 1. Square the x, multiply the 2 together, and change the sign, and then square the 1. And there we have it. Oh, you know what, though? We did x cubed minus 1. We forgot. I forgot this is also x cubed plus 1. So I get another factor of x plus 1, and then another x squared, this time minus x plus 1. Pretty complex kind of situation there. All right, let's take a look at the next one. Factor the following. So pause the video and give it a try. All right, hopefully you factored out an n and got n to the 4th minus 9. But recognize that that is actually a difference of two squares, where it's n squared minus 3 and n squared plus 3. And I can't do anything that's a sum, and this is a difference, but 3 is not a perfect square. Now let's factor out an a squared. I'm left with b cubed minus 64. So this is a squared times b minus the cube root of 64 is 4. And then b squared plus 4b plus 16. Y to the 9th minus 52. Y to the 9th minus 52 is y to the... I don't want to do y to the 4/5 as a difference of two squareds, but this is actually a difference of two cubes, believe it or not. This is y cubed minus 8 times y to the 6th plus 8y cubed plus 64. And I also need to do the other side. So that is, no, I need to do, I need to factor the y cubed minus 8. Y cubed minus 8 is y minus 2. And then I have y squared plus 2y plus 4 times y to the 6th plus 8y cubed plus 64. All right, there we have it. For your exit ticket, you're supposed to list the process for factoring by grouping, use number of steps, and do not use more than 3 steps. See you in the next lesson.